In the grand tapestry of life on Earth, few creatures can claim a lineage as ancient and as resilient as the turtle. Their story is etched not only in living forms, but in the very stones of the earth, fossilized shells and bones that whisper of a time when the world was young and untamed. These are not merely reptiles, they are living fossils, voyagers who have drifted through the currents of time for over 300 million years. Their earliest ancestors, the stem turtles, emerged in the late Triassic period, their bodies already bearing the hallmarks of the remarkable adaptations that would define their descendants. They witnessed the rise of the dinosaurs, navigated the cataclysm that saw them fall, and have continued their quiet, methodical existence into our modern world. Fossil records reveal that ancient turtles survived mass extinctions that swept away entire lineages, their sturdy forms persisting through epochs of fire and ice. Their fundamental design, a blueprint of evolutionary genius, has remained remarkably unchanged, a testament to its near-perfect success. The shell, a fusion of ribs and vertebrae, is a marvel of natural engineering, an impenetrable fortress that shields vital organs from predators and environmental hazards alike. They are a symbol of persistence, of slow and steady endurance against the relentless march of ages, carrying the story of the planet within their very bones. The carapace and plastron, unique among vertebrates, offer both protection and support, allowing turtles to retreat entirely within their shells when threatened. Their journey began on land, long before the first great lizards roamed the continents. Fossilized tracks and ancient remains show that the earliest turtles were terrestrial, their limbs adapted for digging and traversing dense undergrowth. From these terrestrial origins they embarked on an evolutionary odyssey, diversifying to conquer nearly every environment imaginable. Over millions of years their bodies transformed. Some developed webbed feet and streamlined shells for aquatic life, while others grew sturdy elephantine legs for life in arid deserts. Some returned to the water, adapting to the gentle currents of freshwater rivers and ponds. Their nostrils shifted upward, allowing them to breathe while nearly submerged, and their eyes evolved to see both above and below the water's surface. Others ventured into the vast, salty expanse of the world's oceans. Sea turtles developed powerful flippers, capable of propelling them across entire oceans, and salt glands to excrete excess seawater, a vital adaptation for marine survival. Today they are found across the globe, from the sun-scorched deserts of Africa to the tropical rainforests of the Amazon. Each environment has shaped their anatomy and behavior, resulting in a dazzling array of forms and survival strategies. Each species is a unique chapter in this epic saga, a variation on a theme of survival that has played out across epochs. Some have evolved domed shells to deflect the jaws of predators, while others possess flat, streamlined bodies for swift movement through water. When observing a turtle, one is often struck by a sense of profound calm and gentleness. Yet beneath this tranquil exterior lies a suite of ancient adaptations, powerful jaws for crushing tough vegetation or prey, and lungs capable of holding a single breath for hours during hibernation or deep dives. Their slow, deliberate movements are not merely a matter of temperament, but a calculated strategy. By conserving energy and minimizing movement, turtles can survive long periods without food or water, enduring droughts and scarcity that would doom less adaptable creatures. They appear to be passive observers of the world, content to move at their own unhurried pace. This patience is a survival tactic, allowing them to outlast threats and wait for the perfect moment to act. Yet this perception, while endearing, only reveals a fraction of their complex nature. Turtles possess acute senses, keen vision, a strong sense of smell, and the ability to detect vibrations through the ground or water, alerting them to danger or opportunity. The story of the turtle is one of incredible diversity in behaviour, from the peaceful grazing of a tortoise whose beak-like mouth is perfectly suited for cropping tough grasses and leaves, to the lightning-fast strike of a fearsome aquatic predator. Some turtles, like the snapping turtle, have evolved powerful neck muscles and razor-sharp jaws, capable of ambushing fish and amphibians with explosive speed. To truly understand these creatures is to look beyond their placid exterior and discover the dynamic and often dramatic lives they lead. Their survival depends on a delicate balance of stealth, strength and adaptability honed over millions of years. Their continued presence on the planet is nothing short of a miracle of evolution. From the moment a hatchling breaks free from its egg, it is equipped with instincts and adaptations that have been refined by countless generations of survivors. In a world defined by constant change and competition, the turtle has found a way not just to survive, but to thrive. Their ability to exploit a wide range of habitats and food sources has ensured their persistence through the ages. They have outlasted countless other species, adapting to shifting climates, changing landscapes, and the emergence of new predators. Their shells bear the scars of ancient battles, and their eyes have witnessed the transformation of continents. Their story is not one of dramatic battles or rapid evolution, but one of quiet strength, of ingenious adaptation, and of an unbreakable will to endure. The turtle's slow metabolism, armoured body and versatile diet are the keys to its ancient success. They are the ancient voyagers, the silent witnesses to the deep history of life, and their journey is far from over. The legacy of the turtle is written in stone and shell, a testament to the power of adaptation and the enduring strength of nature's most patient survivors. The most iconic feature of any turtle is, without question, its shell. This remarkable structure is a defining characteristic, instantly recognizable and unique among reptiles. Far more than simple armor, the shell is a marvel of biological engineering, an integrated, portable fortress that is inseparable from the turtle's own skeleton. The shell is composed of two main parts, the upper carapace and the lower plastron, both made of bone and covered by tough, keratinous scutes. The carapace, the domed upper section, is fused directly to the turtle's vertebrae and ribs. This means the shell is not an external suit, but a living extension of the turtle's body, providing both structure and protection. The turtle can never leave its shell. It is, quite literally, its home. The bony dome of the shell is so robust and perfectly constructed that it can withstand tremendous force, such as the crushing bite of powerful predators. Its strength comes from the intricate arrangement of bones and the overlapping scutes, which distribute pressure and resist penetration. For many species, the ability to retract their head and limbs inside the shell creates an almost impenetrable barrier. The shell becomes a sanctuary, a safe room where the turtle can remain protected from danger until the threat has passed. Yet, the shell's function extends far beyond defense. It is a multi-purpose adaptation serving as both shield and tool. For these cold-blooded reptiles, the shell is essential for thermoregulation. Turtles rely on external sources of heat to regulate their body temperature, and the shell plays a central role in this process. The broad, often dark surface of the shell acts as a personal solar panel, absorbing the sun's rays with remarkable efficiency. The shell's coloration and structure maximize heat absorption, allowing the turtle to warm up quickly after a cool night or period of inactivity. By basking on a log or a sunlit rock, a turtle can gather the heat it needs to power its metabolism, digest its food, and fuel its movements. The shell's design ensures that the turtle can efficiently harness solar energy, a vital adaptation for survival. When temperatures rise too high, the turtle can retreat into the shade or slip into the water. In these moments, the shell acts as a shield, protecting the turtle from overheating and helping to maintain a stable internal environment despite external extremes. The underside of the shell, called the plastron, is equally vital. It provides protection for the turtle's softer underparts and in some species has evolved specialized features. In certain turtles, such as the striped mud turtle, the plastron is equipped with a hinge. This evolutionary innovation allows the turtle to close its shell tightly, sealing the front and back openings almost completely. With this adaptation, the turtle can create a nearly airtight barrier, further enhancing its defense against would-be attackers. Even the most persistent predators find it nearly impossible to breach this living lockbox, as the shell offers no purchase or weakness to exploit. The result is a self-contained defense system, rendering the turtle virtually impregnable to most threats in its environment. The diversity of shell shapes and structures across turtle species is a testament to the power of evolution. Over millions of years, the basic design has been refined and adapted to meet the challenges of different habitats and lifestyles. Land-dwelling tortoises, for example, possess high domed shells that maximize strength and protection, allowing them to withstand the rigors of terrestrial life. In contrast, marine turtles have evolved flattened, streamlined shells, perfectly shaped for gliding through water with minimal resistance, enhancing their swimming efficiency. Each shell tells a story. Its shape, color and markings reveal the turtle's habitat, lifestyle and the challenges it has faced throughout its life. The shell is a living record, chronicling the environment in which the turtle lives and the dangers it must overcome. More than a passive shield, the shell is an active, growing part of the turtle. It expands as the turtle matures, continually protecting and supporting the animal, while also harnessing the energy of the sun to sustain life. The shell is the key to the turtle's enduring success, a masterpiece of form and function perfectly adapted to serve as both fortress and solar panel, ensuring survival in a world of constant change. Turtles are, for the most part, solitary creatures, each one embarking on a journey through life alone. From the moment they hatch, they are left to their own devices, relying solely on instinct and the environment to guide them. Whether navigating the tangled undergrowth of a forest, gliding silently through the depths of a river, or crossing the open expanse of a sandy beach, turtles chart their own course, rarely seeking the company of others. Unlike many animals that form complex social groups, turtles are largely indifferent to the presence of their own kind. They do not communicate in elaborate ways, nor do they hunt or forage together. Each turtle claims its own patch of territory, moving through the world as a solitary sentinel. Interactions between turtles are fleeting and purposeful, most often limited to the brief encounters required for reproduction. Even these moments are marked by a sense of detachment, as if the turtles are compelled by ancient instincts rather than any social bond. After mating, the male and female part ways, each returning to their solitary existence. There is no lingering partnership, no shared parental duties, just a return to the quiet pursuit of survival. This solitary lifestyle is a survival strategy. By living alone, turtles reduce competition for food and basking spots, ensuring that each individual can focus on its own needs without interference, yet beneath this calm exterior lies a spirit of determination. The solitary turtle is ever alert, its senses finely tuned to the subtle changes in its environment, ready to react to threats or opportunities. The image of the turtle as a slow, gentle creature is shattered during the mating season. In these moments, the tranquility of their world gives way to sudden bursts of aggression. Males compete fiercely for access to females, engaging in intense battles that can be both violent and relentless. These confrontations are displays of strength and stamina, where only the most determined prevail. The African spurred tortoise, the largest continental tortoise, exemplifies this dramatic side of turtle life. Its size and power make its territorial disputes especially formidable. Rival males engage in powerful shoving matches using the hardened gular scutes on their shells as battering rams. The force of these collisions echoes through the landscape, a testament to their raw strength. The ultimate goal is to flip the opponent onto his back, a move that can determine life or death. Once overturned, a tortoise is left vulnerable, unable to right itself on the unforgiving ground. The highly convex shell, so effective for protection, becomes a prison when the tortoise is flipped. Struggling in vain, the defeated male faces a dire predicament. Exposed to the relentless sun, the overturned tortoise is at the mercy of the elements. The heat and vulnerability can quickly become fatal. As the weight of his own organs presses down on his lungs, the tortoise may suffocate or succumb to the heat, a stark reminder of the harsh realities of survival. These brutal contests are not mere displays. They are essential for ensuring that only the strongest and most resilient individuals pass on their genes, shaping the future of the species. The primal struggle for dominance and territory is a defining feature of turtle life, underscoring the high stakes of reproduction in the wild. Aggression and territoriality are not limited to land-dwelling tortoises. In aquatic environments, turtles are equally assertive, defending their chosen territories with vigour. Underwater, turtles engage in fierce battles for basking spots, feeding grounds, and access to mates. These confrontations can be swift and explosive, disrupting the calm of their watery world. The snapping turtle, with its powerful jaws and unyielding temperament, is a formidable defender of its territory, ready to confront any rival that dares to intrude. During the breeding season, persistent males pursue females relentlessly, their determination driving them through the currents in pursuit of a mate. Even the most tranquil waters can erupt into chaos as turtles clash, their solitary lives momentarily interrupted by the demands of competition and survival. The peace of a solitary basking turtle can be shattered in an instant, as rivals appear and aggression flares, transforming a quiet moment into a struggle for dominance. In the end, the solitary turtle's life is a delicate balance of vigilance, resilience and, when necessary, fierce aggression, a testament to the survival tactics that have allowed these ancient voyagers to endure for millions of years. For turtles, the world is a tapestry woven from invisible threads of scent. While their eyesight is keen, it is their extraordinary sense of smell that truly shapes their experience of life, guiding their every move and decision. Turtles possess a highly specialized olfactory system. Their nostrils, positioned at the tip of their snouts, are lined with sensitive olfactory epithelium, tissue rich in receptor cells that detect even the faintest chemical cues in the air or water. These receptors send signals directly to the turtle's brain, where scents are analyzed and interpreted with remarkable precision. In aquatic turtles, water flows through the nostrils and over the olfactory epithelium, allowing them to sample the chemical composition of their environment. They can detect the subtlest traces of prey, such as fish or invertebrates, carried on the currents. On land, tortoises rely on airborne scents to locate food. Their sense of smell is so acute that they can follow the aroma of ripening fruit or fresh vegetation from great distances, even when the source is hidden from view. This powerful olfactory ability is the turtle's primary tool for interpreting the world. Every moment they are immersed in a stream of chemical information which guides their choices about where to travel, what to eat, and when to seek out others of their kind. Scent-based navigation is essential for survival. Turtles use their sense of smell to distinguish between safe and dangerous foods, to avoid predators and to find suitable habitats. The olfactory system is constantly at work, processing a complex array of signals that inform every fundamental decision. The tongue plays a crucial role in this sensory world. When a turtle flicks its tongue, it collects chemical particles from the environment and transfers them to the Jacobson's organ or vomeronasal organ located in the roof of the mouth. This organ acts as a sophisticated chemical laboratory, analyzing the composition of potential food items or unfamiliar objects. When a turtle encounters something new, it will often test it with a gentle touch of its tongue, gathering detailed chemical data. This is not simply a matter of taste. The turtle is conducting a thorough analysis, searching for signs of toxicity, ripeness, or nutritional value. By tasting the air or an object, the turtle can determine whether it is safe to eat or best avoided. This careful process is vital for survival, allowing turtles to avoid poisonous plants or spoiled food that could cause harm. Only after this meticulous examination will a turtle decide to consume the item, ensuring that it will nourish rather than sicken them. If the scent signals danger or decay, the turtle will move on, guided by its acute chemical senses. This methodical approach is a hallmark of turtle behavior, a slow and deliberate quest for sustenance that depends on the reliability of their olfactory system. Once satisfied, the turtle consumes its chosen meal, confident in the safety and nutritional value of its selection. Scent is also the language of turtle communication, especially during the intricate rituals of mating. Male turtles are able to detect pheromones, unique chemical signals released by receptive females. These pheromones are carried on the wind or water, forming invisible trails. Following these trails, a male can locate a female even if she is hidden from sight, tracking her over long distances and through challenging terrain. This olfactory pursuit can last for days or even weeks, with the male guided solely by the chemical signals left behind. The journey is patient and persistent, a testament to the power of scent in the turtle's world. The male's unwavering focus is a direct result of his ability to interpret these chemical cues. The female too uses scent to assess the suitability of a potential mate, reading the molecular messages carried in his own pheromones. This exchange is a silent, invisible conversation, a dialogue of molecules that determines the future of their species. Through scent, turtles ensure the continuation of their ancient lineage, passing on their genes in a world where communication is written in chemistry. Some aquatic turtles have evolved even further, developing the ability to absorb oxygen directly from the water through their cloaca, a multi-purpose orifice at their rear. This adaptation, known as cloacal respiration, allows them to remain submerged for long periods, sometimes up to an hour, without surfacing for air. While underwater, turtles continue to sample the chemical makeup of their surroundings, using their olfactory system to detect the presence of predators, prey, and other turtles. This hidden sense allows them to remain alert and aware, even in the depths of their aquatic world. The ability to perceive and interpret chemical signals is a constant, silent companion, shaping every aspect of a turtle's existence. Even as they glide through the water or rest among aquatic plants, turtles are attuned to the ever-changing chemical landscape, responding instantly to new information. A sudden shift in scent can trigger a rapid response, an escape from danger, a pursuit of prey, or a search for a mate. This hidden sense is a deep and intimate connection to their world, a way of knowing that is both ancient and enduring. For turtles, scent is not just a sense, it is the very language of life, guiding them through the mysteries of their ancient, ever-changing realm. The solitary life of the turtle is cast aside in one of nature's most breathtaking spectacles, the aribada. But the journey of reproduction for turtles begins long before this mass gathering. with a series of intricate courtship rituals that vary across species. In the open ocean, male turtles seek out females, often guided by chemical cues and subtle movements in the water. For some species, like the green sea turtle, males approach females with gentle nuzzles and nips, circling and stroking her shell with their flippers in a delicate underwater ballet. Once a female accepts a suitor, mating takes place in the water, sometimes with several males vying for a single female. Loggerhead turtles, for example, may be seen with multiple males clinging to a female's carapace, each hoping to pass on his genes. After mating, females store sperm for weeks or even months, allowing them to fertilize multiple clutches of eggs throughout the nesting season. The timing of nesting is synchronized with incredible precision, typically occurring from August to November, about 10 days before the new moon for olive ridleys, while other species like leatherbacks may nest at different times and on different beaches. The quiet shoreline is transformed into a bustling maternity ward, a moving sea of shells as countless mothers-to-be haul themselves ashore to fulfill their ancient duty. Some, like the Kemp's ridley, nest in daylight, while others, such as hawksbills, prefer the cover of night. Each female, driven by an instinct honed over millennia, digs a deep, flask-shaped chamber in the sand with her powerful rear flippers. The shape and depth of the nest can differ by species. Leatherbacks dig especially deep nests, while flatbacks create shallower ones. Into this safe incubator, she deposits a clutch of around 100 soft, leathery eggs. The number of eggs varies. Leatherbacks may lay over 100, while flatbacks lay fewer, larger eggs. The sheer scale of the aribada is a strategy for survival, but other species employ different tactics. Some, like the loggerhead, nest alone, spreading their eggs across many beaches to reduce the risk of total loss. By nesting all at once, the olive ridleys overwhelm potential predators, while solitary nesters rely on stealth and dispersal. Vultures, coyotes, and crabs can only consume so many eggs and hatchlings. For solitary nesters, the scattered nests make it harder for predators to find them all. The vast numbers or scattered strategies ensure that a significant portion will survive this initial onslaught. It is a classic example of safety in numbers, or safety in secrecy, a biological flood or a hidden treasure designed to guarantee that the next generation has a fighting chance. The fate of these eggs lies buried in the sand, their development governed by the ambient temperature. For many turtle species, temperature determines the sex of the offspring. In some, like the green turtle, warmer sands produce more females, while cooler conditions favour males. The placement of the nest, under vegetation, in the open or in shaded areas, can influence the temperature and thus the sex ratio of the hatchlings. This phenomenon, known as temperature-dependent sex determination, adds another layer of vulnerability to their life cycle, as climate change and rising global temperatures could potentially skew sex ratios, threatening the long-term stability of populations. For weeks, the embryos develop within their protective shells, preparing for the most perilous journey of their lives. Some species, like the leatherback, have longer incubation periods than others. When the time comes, the tiny hatchlings must orchestrate their escape. In some species, siblings coordinate their movements, pushing upward together to break through the sand. Using a small, temporary egg tooth on the tip of their snout, they painstakingly break free from their shells, a process that can take several days. They then face the daunting task of digging their way up through the sand, often coordinating their efforts to emerge together, usually under the cover of darkness. Some, like the flatback, may emerge during the day, risking greater predation. Once on the surface, they are driven by a single powerful instinct to reach the sea. This frantic dash across the beach is a race against time and a gauntlet of hungry predators. Some hatchlings rely on camouflage, while others move in large groups to increase their odds, a desperate scramble for the safety of the waves. The journey of each hatchling is a testament to the diversity and resilience of turtle reproduction, a symphony of survival played out on beaches around the world. The world of turtles is a realm of ingenious survival, where countless species have evolved a dazzling array of deception and defense mechanisms to thrive in their unique habitats. From the dense jungles and murky rivers to sun-baked wetlands, turtles are true masters of disguise, mimicry and protection. Among the most remarkable is the mata-mata turtle of the Amazon River basin, a living illusionist of the aquatic world. This turtle is a master of camouflage and ambush, blending seamlessly into its environment. Its flattened, gnarled shell, often covered in algae, and its head and neck adorned with fleshy, leaf-like appendages, allow it to perfectly mimic a piece of decaying wood or a pile of rotting leaves on the riverbed. This disguise is so effective that even the sharpest-eyed predators and prey can overlook its presence. Remaining almost perfectly still, the mata-mata becomes a patient predator, waiting for an unsuspecting fish to swim within range of its bizarre, smiling mouth. The mata-mata's hunting technique is as strange as its appearance, relying on stealth and surprise rather than speed. It does not chase its prey, but instead waits, motionless, for the perfect moment. When a fish ventures too close, the mata-mata opens its enormous mouth with lightning speed. This sudden movement creates a powerful vacuum, instantly sucking the fish and a large volume of water into its gullet. The water is then slowly expelled, leaving the helpless fish to be swallowed whole. This method is both energy efficient and highly effective in the turbid waters of the Amazon. The mata-mata's cryptic coloration and stillness make it nearly invisible, a ghostly presence in the river that strikes without warning, embodying the art of ambush predation. In the rivers of North America, another formidable predator demonstrates a different form of deception, the alligator snapping turtle. The largest freshwater turtle in the world, it can weigh over 100 kilograms and live for more than 150 years. Its size and longevity are testament to its survival strategies. This behemoth employs a cunning strategy of deception, lying motionless and camouflaged on the river bottom. With its powerful jaws agape, it reveals a unique adaptation that sets it apart from other turtles. Part of its tongue is modified to look exactly like a small, wriggling red worm, a perfect example of mimicry in the animal kingdom. This fleshy lure, wiggled enticingly, proves irresistible to passing fish searching for an easy meal. When a fish moves in to investigate, the turtle's jaws snap shut with tremendous force, a living trap sprung with lethal speed and power. This is aggressive mimicry at its finest, where the hunter uses a part of its own body as bait to lure prey directly into its mouth. By remaining motionless and letting prey come to it, the alligator snapping turtle conserves energy, a vital adaptation for such a massive reptile. Other turtles, like the Spanish pond turtle, display their mastery of survival through different means, relying on patience and timing. Their hatchlings may remain buried underground for months after breaking from the egg, waiting patiently for seasonal rains to soften the soil. This remarkable feat of endurance ensures they emerge only when conditions are favourable, avoiding predators and harsh environments. For many turtles, the shell itself is the ultimate defence. Its domed, bony structure acts as a living fortress, allowing turtles to withdraw their vulnerable heads and limbs at the first sign of danger, presenting a nearly impenetrable barrier to would-be attackers. Some species employ warning coloration or intimidating displays, hissing loudly or lunging at threats to startle predators and buy precious moments to escape. Others, like soft-shell turtles, use their flattened bodies and muted colours to bury themselves in sand or mud, vanishing from sight and evading detection. Certain turtles even possess chemical defences, releasing foul-smelling musk from glands near their tails to deter persistent predators. When all else fails, many turtles rely on their powerful limbs and streamlined bodies to make a swift escape, diving into water or dense vegetation to evade capture. Through camouflage, mimicry, and a suite of defensive behaviours, turtles have become enduring symbols of resilience and adaptability, surviving for millions of years by mastering the art of deception and defence. Across the globe, turtles have evolved a remarkable array of dietary strategies, each finely tuned to their unique habitats. Broadly, these ancient reptiles fall into two dietary camps, the predominantly herbivorous land dwellers and the mostly carnivorous aquatic species. This division is not just a matter of preference, but a reflection of millions of years of adaptation and ecological necessity. Tortoises, the steadfast wanderers of terrestrial landscapes, are quintessential herbivores. Their daily routines revolve around slow, deliberate foraging as they traverse grasslands, forests and arid plains in search of sustenance. Their diets are rich in a variety of plant matter: grasses, wildflowers, succulent fruits, fibrous stems and tough leaves. Their powerful beak-like mouths are perfectly engineered for tearing through resilient vegetation, allowing them to access nutrients locked within hardy plant tissues. As they feed, tortoises inadvertently become gardeners of their ecosystems, consuming fruits and dispersing seeds far and wide through their droppings. This not only shapes plant communities but also supports the regeneration of their habitats. The African spurred tortoise, for instance, is a master of survival in harsh, arid environments. It grazes extensively on grasses and succulents, using its formidable strength to push aside obstacles and reach the most nourishing plants. This peaceful, plant-based existence provides a steady, slow-release source of energy, perfectly suited to their unhurried pace of life. While meat is rarely on the menu, some tortoises may opportunistically scavenge, but their primary strategy is patient, methodical foraging, a stark contrast to their aquatic relatives. In aquatic realms, the story shifts dramatically. Most freshwater and marine turtles are active predators, relying on animal protein to fuel their more energetic lifestyles. Their diets are as diverse as their habitats, shaped by the availability of prey and the turtle's own size and hunting abilities. Smaller species, such as the striped mud turtle, patrol the shallows, seeking out insects, snails and worms. Larger, more formidable species like the alligator snapping turtle are apex predators in their environments, capable of ambushing fish, amphibians, and even the occasional small mammal or water bird that strays too close to the water's edge. Their hunting adaptations are as varied as their prey, from the alligator snapper's worm-like tongue that lures fish, to the swift pursuit tactics of more agile swimmers. These carnivorous turtles play a crucial role in controlling populations of aquatic animals, maintaining balance within their ecosystems. Sea turtles, too, display a spectrum of feeding behaviours. The green sea turtle, unique among its marine kin, shifts to a mostly herbivorous diet as an adult, grazing on lush seagrass beds and helping to keep these underwater meadows healthy and productive. In contrast, the loggerhead turtle is a powerful carnivore, using its massive jaws to crush the armoured shells of crabs, conchs and other hard-shelled invertebrates. The leatherback sea turtle, a true giant of the open ocean, specialises in hunting jellyfish. Its throat is lined with backward-pointing spines, ensuring that slippery prey cannot escape once captured. By consuming vast numbers of jellyfish, leatherbacks help regulate jellyfish populations, which in turn influences the health of entire marine food webs. From the gentle, slow-moving herbivores that shape plant communities, to the swift predatory carnivores that keep animal populations in check, Turtles are vital architects of their environments. Their dietary choices, honed by evolution, not only ensure their own survival, but also weave them into the very fabric of the ecosystems they inhabit. Each species a testament to the power of adaptation and the intricate balance of nature. The story of the turtle is a saga of survival and adaptation, a quiet yet relentless conquest of nearly every major habitat on Earth. Across millions of years, turtles have evolved to thrive on land, in rivers and throughout the vast oceans, each environment shaping their bodies and behaviours in remarkable ways. Their journey began on land. The earliest turtles were terrestrial, their sturdy domed shells and thick elephantine legs providing protection and support as they navigated solid ground. These ancient tortoises were built for endurance, their heavy armour shielding them from predators, while their powerful limbs allowed them to traverse rocky terrain and dig burrows for shelter. Today's tortoises are the living legacy of these pioneers. They roam deserts, forests and grasslands, their slow, deliberate movements a testament to patience and resilience. In the arid desert, tortoises survive extreme heat and scarce water by burrowing underground and storing moisture in their bodies. In forests, they blend into the undergrowth, foraging for plants and fruits. On the savanna, they graze on tough grasses, their jaws adapted to crush fibrous vegetation. Their shells are fortresses, offering unmatched defense against predators, while their slow metabolism allows them to endure long periods without food or water. Yet the call of water was irresistible for many turtle lineages. Some ventured from land to the edges of ponds and rivers, beginning a new chapter in their evolutionary story. In these freshwater realms, turtles adapted to a life of duality, at home both in water and on land. Their bodies transformed to meet the challenges of aquatic life. Over generations, shells became flatter and more streamlined, reducing resistance as they glided through water. This new shape allowed them to move swiftly, escaping predators and pursuing prey beneath the surface. Their feet, once sturdy pillars for walking, developed webbing between the toes, transforming into efficient paddles for swimming and manoeuvring in swift currents. Freshwater turtles became skilled hunters, catching fish and invertebrates, yet always returning to land to bask in the sun or lay their eggs, maintaining a vital link to their terrestrial origins. The most extraordinary adaptation, however, was the leap into the open ocean. Some turtles evolved to conquer the vast, unpredictable seas. Around 150 million years ago, a lineage of turtles fully embraced marine life, giving rise to the sea turtles, masters of the world's oceans. This transition demanded dramatic changes. Their limbs became powerful, wing-like flippers, perfectly designed for long-distance swimming. With these flippers, sea turtles glide effortlessly through the water, covering vast distances with grace and speed. Their shells became lighter and more streamlined, enhancing buoyancy and reducing drag, allowing them to float and dive with ease. Sea turtles are true global voyagers, embarking on epic migrations that span thousands of miles, crossing entire ocean basins in search of food and nesting grounds. These three lifestyles, terrestrial, freshwater and marine, demonstrate the turtle's extraordinary ability to adapt and survive in radically different worlds. The basic blueprint remains: a protective shell and 4 limbs. But evolution has refined and reshaped these features, tailoring each turtle to its unique environment. The lumbering tortoise, the agile pond slider, and the majestic sea turtle are all variations on a single, remarkably successful design. Turtles are living proof that a simple, effective design, shaped by time and adaptation, can conquer the land, the rivers, and the boundless deep blue sea. To contemplate the turtle is to contemplate deep time itself, to witness a lineage that stretches back to the dawn of the animal kingdoms. These creatures are living monuments to endurance, their presence a silent chronicle of survival through ages of shifting continents and changing seas. They have seen the rise and fall of ancient reptiles, the blossoming of forests, and the great migrations of countless animal kin. Their success is not measured by speed or dominance, but by a design of profound simplicity and effectiveness. The protective shell, the adaptable metabolism, and the versatile body plan have provided them with the tools to persist through eons of transformation, adapting to deserts, rivers, forests, and oceans alike. They are a quiet testament that in the long race of evolution, it is not always the swift or the mighty that prevail, but the resilient and the adaptable. From the patient ambush of the Matamata to the epic migrations of the olive ridley, their lives are woven with ingenious strategies for survival. Turtles have mastered the arts of camouflage, blending seamlessly into their environments, evading predators and waiting patiently for opportunity. They are skilled in deception and defense, their shells a fortress against the dangers of the wild. They have developed complex methods for finding food, for navigating vast distances, and for ensuring the continuation of their kind against overwhelming odds. The journey of a hatchling from its sandy nest to the open ocean is one of nature's most perilous and inspiring sagas, a desperate scramble for life that has played out on countless beaches for millions of years, a cycle of renewal that connects the present to the distant past, echoing through the animal kingdoms. Their story is one of incredible diversity, a single ancestral blueprint modified to create the lumbering tortoise of the desert, the stealthy hunter of the river, and the graceful voyager of the sea. Each species is a master of its own realm, a unique solution to the puzzle of existence. Whether grazing on plants, crushing shellfish, or luring fish into a trap, turtles have found a way to thrive in nearly every corner of the globe, their presence shaping the balance of ecosystems. Their legacy is etched into the very fabric of the natural world, their movements and habits influencing the lives of countless other creatures. A slow but steady presence, turtles shape their environments, dispersing seeds, maintaining aquatic vegetation, and providing shelter for smaller animals. As they continue their ancient journey, turtles face new challenges in their ever-changing world, obstacles that test the limits of their adaptability and resilience. Yet if their past is any indication, they possess a deep-seated resilience that has carried them through the harshest of epochs. They are the ultimate survivors, the ancient architects of their own destiny, shaping the world around them with every deliberate step. Their shells carry more than just their bones. They carry the weight of ages, a living record of the Earth's memory. A history of persistence written over 300 million years, their lineage a thread woven through the tapestry of life. The turtle moves through the world as it has always done, slowly, deliberately, and with a timeless grace that commands the respect and admiration of all who share the animal kingdoms. Their legacy is a testament to the enduring power of patience, adaptation, and quiet strength. Gap 2S. The story of the turtle begins not with the creatures we recognize today, but deep within the primordial swamps of the late Triassic period over 220 million years ago. Here, among the towering ferns and giant amphibians, the ancestors of turtles first emerged. Small, enigmatic reptiles whose bodies hinted at the beginnings of a shell. Fossil discoveries, like the ancient Odontoceles from China, reveal a half-formed plastron, a belly shield that marks the first steps toward the armoured protection we associate with turtles. Over millions of years, this protective structure evolved, encasing the body in a bony fortress that would become the defining feature of the turtle lineage. Gap 2S. As continents drifted and climates shifted, turtles adapted. The fossil record uncovers remarkable forms. Archelon, the giant sea turtle of the Cretaceous, gliding through ancient oceans with flippered limbs spanning over 4 meters. Progonocales, with its fully developed shell and spiked tail, crawling through prehistoric woodlands, impervious to most predators of its age. Gap2S. Genetic studies have added new layers to this ancient narrative. By sequencing DNA from modern turtles and comparing it to their reptilian relatives, scientists have traced the turtle family tree with newfound clarity. They are not close kin to lizards or snakes, as once thought, but share a deeper ancestry with crocodilians and birds, together forming a group known as Archosauria. This surprising connection is etched into the very code of their cells, a genetic echo of shared origins stretching back to the dawn of reptiles. Gap2S. Through mass extinctions and the upheaval of continents, turtles persisted. Some adapted to freshwater rivers, evolving streamlined shells and powerful jaws. Others ventured onto land, growing massive and long-lived, their domed shells protecting them from the harsh sun and hungry predators. Still others returned to the sea, mastering the art of long-distance migration and developing salt glands to survive in oceanic realms. Gap2S. Today, the diversity of turtles, over 350 species, stands as a living testament to their evolutionary journey. Each species, from the tiny bog turtle to the majestic leatherback, carries the legacy of ancient adaptations honed by time. The fossilized bones, the genetic blueprints, and the living turtles themselves are all chapters in a story that spans epochs. Through every upheaval, every changing age, turtles have endured, ancient survivors on a journey that continues unbroken into the present day. From the moment a hatchling bursts free of its shell and scrambles toward the surf to the epic odyssey of adult turtles across entire oceans, one question has fascinated scientists for decades. How do turtles find their way? Gap1S. The answer lies in a suite of remarkable navigational tools, evolved over millions of years, that allow turtles to traverse vast landscapes and open seas with astonishing precision. Gap1S. At the heart of this navigational prowess is the ability to detect Earth's magnetic field. Turtles are equipped with specialized sensory cells that act as a biological compass, allowing them to perceive subtle variations in magnetic intensity and inclination. Each stretch of coastline, each region of ocean possesses a unique magnetic signature, an invisible map that turtles can read and remember. Gap1S. This geomagnetic sense is so finely tuned that loggerhead hatchlings released on distant beaches have been observed to swim thousands of kilometers, only to return as adults to the very sands where they were born. In controlled experiments, scientists have altered magnetic fields in laboratory tanks and watched as young turtles instinctively reoriented themselves as if consulting an internal compass. Gap1S. But the story doesn't end with magnetism. As they mature, some turtle species also use celestial cues, tracking the position of the sun, moon, and even the polarization of light reflected off the water's surface to refine their bearings. This multi-layered approach allows turtles to adjust their course even when clouds or currents obscure their path. Gap1S. Case studies from around the world reveal the extraordinary scope of turtle navigation. Green sea turtles tagged with satellite transmitters have been tracked migrating more than 2,000 kilometers from their nesting beaches to distant feeding grounds, navigating with unerring accuracy across open water. In Florida, experiments with artificial lighting and altered horizons have shown how hatchlings use the brightest line on the horizon, the reflection of moonlight on the sea, to guide their first journey. Gap1S. The mysteries of turtle navigation are still being unravelled, but one thing is clear. These ancient mariners possess a navigational toolkit unlike any other, forged by evolution and refined by millennia of migration. Whether crossing continents or oceans, turtles follow invisible trails written into the very fabric of our planet, a silent testament to the wonders of nature's compass. From the instant a turtle hatches, the world is filled with danger. On the journey from nest to water, hatchlings are vulnerable to a gauntlet of natural predators, crabs, birds and fish lying in wait for an easy meal. Only a small fraction survive this perilous dash, a testament to the harsh odds of nature's lottery. Yet the perils do not end at the shoreline. In the water, young turtles must evade swift predators such as sharks and large fish. Even as adults, their armoured shells are not impenetrable. Certain crocodiles and predatory mammals have developed the strength and cunning to breach these ancient defences. Environmental threats are equally formidable. Shifting currents, violent storms and fluctuating temperatures can disrupt vital nesting and feeding grounds. Rising sea levels may inundate nesting beaches, while unpredictable weather can destroy eggs before they ever hatch. To endure these relentless threats, turtles have evolved a suite of survival strategies. Camouflaged shells blend seamlessly with sand and seaweed, while their slow, deliberate movements reduce the chance of detection. Some species lay hundreds of eggs at once, overwhelming predators with sheer numbers, ensuring that at least a few will survive. But the greatest threat of all may be the changing climate itself. Warmer sands can alter the sex ratio of hatchlings, while shifting ocean currents affect the distribution of food. As habitats transform, turtles must adapt or face an uncertain future. In this ever-changing world, turtles remain resilient, symbols of survival in the face of relentless adversity. Their journey is a daily battle, fought with ancient instincts and timeless determination. Beneath the stillness of their ancient armour, turtles possess a hidden world of communication, one often overlooked by the human eye. Unlike creatures that fill forests or oceans with raucous calls, turtles are masters of subtlety, conveying messages through a symphony of quiet signals. Some species, like the red-eared slider, produce low-frequency vocalizations, especially during courtship or territorial disputes. These soft grunts and clicks, barely audible to humans, carry through the water, reaching potential mates or warning rivals away. Body language is another vital tool. Males may bob their heads, flutter their claws, or circle one another in elaborate displays of dominance or affection. When threatened, a turtle might retract into its shell with deliberate slowness, broadcasting its discomfort or unease to any onlookers. Chemical cues add yet another layer. Female sea turtles, for example, release specific scents into the water as they approach nesting beaches. These chemical trails guide males over vast distances, ensuring the continuation of the species. Even hatchlings, fresh from their nests, communicate through vibrations. Synchronized movements beneath the sand signal siblings that it's time to emerge together, overwhelming predators with their numbers. Through vibrations, scents, and the quiet choreography of their bodies, turtles share information vital for survival and reproduction. In the silent world of the shell, conversation is all around. An ancient language spoken in gestures, scents, and subtle sounds echoing through the ages. Across the animal kingdom, few creatures rival turtles in their longevity. Some species, like the Galapagos giant tortoise, can live over 100 years, with documented cases of individuals surpassing a century and a half. Even smaller freshwater turtles and sea turtles regularly outlive many other vertebrates, often reaching ages of 40, 60 or more. But what grants turtles such remarkable lifespans? Scientists believe it's a combination of slow metabolism, protective shells and unique cellular processes. Unlike many animals, turtles exhibit negligible senescence, the gradual deterioration associated with aging. Their cells repair DNA damage efficiently, and some species show little decline in reproductive ability or organ function even in advanced age. Environmental factors also play a crucial role. Access to clean water, abundant food sources, and safe nesting sites significantly impact survival. Predation, habitat loss, and human interference, however, can drastically shorten a turtle's natural lifespan. Intriguingly, turtles' aging process continues to fascinate researchers. Studies have revealed that their immune systems remain robust for much of their lives, and certain turtles possess enzymes that help combat oxidative stress, a key factor in aging. Despite their defenses, turtles are not immortal. Natural wear, disease, and external threats eventually take their toll. Yet in their tranquil pace and enduring presence, turtles embody the mysteries of longevity, living testaments to the resilience of life and the secrets that time alone can tell. From the sun-drenched sands of desert dunes to the lush canopies of tropical rainforests, turtles have carved out a place in nearly every corner of the world. Their remarkable adaptability is reflected in the diversity of habitats they call home, each demanding its own unique set of survival skills. In freshwater rivers and lakes, soft-shell turtles glide beneath the surface, their flattened bodies and snorkel-like noses perfectly suited for a life spent submerged. Here, aquatic plants, muddy bottoms, and gentle currents shape their daily routines. Painted turtles bask on logs, their shells absorbing the sun's warmth to regulate their body temperature. Venture into dense rainforests and you'll find forest-dwelling turtles navigating the leaf-littered floors. Camouflage shells blend seamlessly with moss and fallen branches, offering protection from lurking predators. These turtles feed on fruits, fungi, and invertebrates, their diets as varied as the ecosystem itself. In arid deserts, tortoises become masters of water conservation. Their domed shells shield them from harsh sunlight, while strong, sturdy legs allow them to traverse rocky terrain in search of sparse vegetation. Many dig burrows deep into the earth, escaping the heat and preserving precious moisture. Along coastlines and in the open ocean, sea turtles embark on epic migrations. Hatchlings emerge from sandy nests under the cover of night, racing toward the waves guided by moonlight. Adults navigate vast stretches of sea, their streamlined bodies built for endurance as they travel between feeding grounds and nesting beaches. Even high mountain valleys and remote islands provide sanctuary for certain turtle species, each population finely tuned to its environment. Whether braving swift rivers, humid jungles, scorching deserts, or the boundless sea, turtles exemplify nature's ingenuity, surviving and thriving wherever their journey takes them, shaped by the world's astonishing variety of habitats. Beyond their fascinating adaptations, turtles play a quiet but crucial role in maintaining the balance of the ecosystems they inhabit. In wetlands and rivers, turtles help control aquatic vegetation and insect populations, acting as natural gardeners and pest managers. Their grazing keeps plant growth in check, preventing overgrowth that could otherwise choke waterways and disrupt the delicate balance of aquatic life. On forest floors, turtles become seed dispersers. As they forage on fruits and fungi, they inadvertently transport seeds across the landscape, giving rise to new plants and supporting the regeneration of forests. This subtle act of seed dispersal helps maintain plant diversity, which in turn sustains countless other creatures. In the ocean's vast expanse, sea turtles are instrumental in keeping seagrass beds healthy. By feeding on seagrass, they encourage its growth and productivity, which provides shelter and nourishment for a myriad of marine species. The presence of turtles also regulates jellyfish populations, as some species consume these gelatinous creatures, preventing their numbers from spiraling out of control. Turtles themselves are woven into the web of life as both predator and prey. Their eggs and hatchlings feed an array of animals, from crabs and birds to fish and mammals, supporting the survival of many other species. Even in death, turtle shells become shelters for insects and small animals, continuing to serve the ecosystem long after their original inhabitants have gone. Through these natural conservation mechanisms, turtles quietly uphold the health and harmony of their environments. Their presence ripples through food webs and environmental cycles, reminding us that every creature, no matter how ancient or unassuming, has a vital part to play in the story of life on Earth. Beneath the iconic shell lies a marvel of natural engineering and anatomical design perfected over millions of years. The turtle's skeleton is a unique fusion of armor and agility. Its ribcage and spine are fused directly to the carapace, forming a protective shield that guards the internal organs from predators and environmental hazards. This bony shell is complemented by the plastron, the ventral shield, which together create a nearly impenetrable fortress. Muscles are expertly arranged to allow surprising mobility. Though seemingly slow, the limbs are powered by strong, specialized muscles that enable turtles to dig, swim, or traverse rugged terrain. Sea turtles, for instance, possess elongated flippers packed with powerful muscles, allowing them to glide effortlessly through the ocean currents, while land-dwelling tortoises have sturdy, column-like legs for steady movement across solid ground. Inside, the organ systems are finely tuned for endurance and adaptation. The lungs, positioned just beneath the carapace, allow for efficient exchange of oxygen, even when the turtle is partially submerged or buried in mud. The heart, with its 3 chambers, supports both aquatic and terrestrial lifestyles by shunting blood as needed, conserving oxygen during long dives. The digestive system is robust, capable of processing a varied diet, whether tough seagrass, crunchy insects or fleshy fruits, extracting every possible nutrient. The turtle's eyes, ears and nasal passages are strategically placed for maximum sensory awareness while remaining protected. The brain, though small, is wired for survival, controlling complex behaviors like navigation and defense. Every bone, muscle and organ works in harmony, crafting a creature built not just to endure, but to thrive in worlds as different as rivers, forests and oceans. This anatomical blueprint is the silent foundation of the turtle's enduring legacy. Beyond their armoured shells and ancient lineage, turtles possess a suite of remarkable senses, finely tuned to their diverse habitats. Their vision, adapted for both air and water, is especially sharp when it comes to detecting movement and distinguishing colours, a vital skill for spotting predators, prey or mates in the shifting light of rivers, forests and oceans. Some species, like sea turtles, can even perceive ultraviolet light, allowing them to navigate the sunlit shallows with ease. Turtles may lack external ears, but their sense of hearing is far from absent. Specialized middle ear bones transmit vibrations from both land and water, enabling them to detect low-frequency sounds, such as the rumble of approaching footsteps or the subtle calls of fellow turtles. Touch is another critical sense. The skin covering their heads, limbs, and even the shell is rich with nerve endings. These tactile sensors alert turtles to changes in their environment, the gentle pressure of shifting sand, the brush of vegetation, or the approach of a curious intruder. Even the shell, though hard, can register vibrations and pressure, helping turtles respond to threats or opportunities. Smell and taste are intricately linked in turtles, with chemoreceptors lining the nasal passages and mouth. These receptors allow turtles to taste the water or air, decoding chemical cues left by food, predators or potential mates, a silent language that guides their behavior. Some species possess a specialized organ known as the Jacobson's organ, further enhancing their ability to detect subtle scents. This heightened chemical sensitivity is especially crucial for navigation and reproduction, as female sea turtles rely on scent trails to locate their natal beaches, and males detect pheromones released by receptive females. Through these finely honed senses, turtles interpret a world invisible to human perception, a world shaped by light, vibration, touch and scent. It is this hidden realm of sensation that enables turtles to survive, adapt and thrive across the globe, from sun-dappled shallows to shadowy forest floors. In the wild tapestry of animal societies, turtles are not just survivors, they are legends. Among the whispering reeds and coral kingdoms, stories about turtles echo from generation to generation of creatures. To the birds that soar overhead, turtles are seen as the patient architects of the earth, their slow and steady pace a symbol of resilience and wisdom. Fish darting through rivers tell tales of the ancient shell-bearers who once shaped the very currents they swim in, guiding lost hatchlings and offering sanctuary beneath their domed shields. In the insect world, ants and beetles marvel at the turtle's home, carried always on its back, a fortress against the storms and floods that sweep through their realms. Even the serpents, masters of camouflage, speak in hushed tones of the turtle's unyielding defence, a shell that turns aside even the sharpest fang. Among the mammals of the forest, young foxes and curious otters listen wide-eyed to stories of the turtle's secret journeys, crossing mountains, rivers and oceans, guided by the stars and the scent of distant rain. In these animal legends, turtles are the wise wanderers, the keepers of secrets, and the silent guardians of the world's oldest paths. Within the animal kingdom, the turtle's story is more than myth. It is a living example of patience, strength, and the art of enduring. Through the eyes of their fellow creatures, turtles are celebrated not just for their ancient lineage, but for the quiet power they carry beneath their shells.